Okay, so this is the x direction. And for the same reasoning, in the y direction, we have sigma Fy equals to 0. And do we have body force? No. Do we have surface force? Yes. So that will be what kind of pressure? In the y direction. So we need to look for surfaces that are perpendicular to the y direction, right? So that will be the front and the back. So the front, the pressure here, which representative can we choose? Let's say we still choose this one, which is Pxyz, or just Py. And on the back side, which one can we choose? Well, we can choose this point, right? This point will be x, y plus dy, z. So the pressure here will be P x y plus dy z. So what will be our equation? P x y z times this area, dx dz, minus P x y plus dy z times, it's also dx dz. So if we divide both sides still by dx dy dz, what do we have? We will have py minus p y plus dy over dy equals to 0. So if we let dy tend to 0, that is, if we let our fluid particle, the volume of our fluid particle to tend to 0, then we end up with dp dy partial p partial y equals to 0. So this thing we can yield partial p partial y equals to 0. Do you agree these two are exactly the same? But the third one has a little variation, which is the body force. Now we need to introduce gravity. Okay, so sigma Fg equals to 0. Now we have body force. But now first let me write out the surface forces. So for the surface force, we need to look for surfaces that are perpendicular to the z direction, which will be the bottom and the top, right? So for the bottom, the forces resulting from pressure will be positive, right? It points at the positive z direction. But on the top, the pressure force will be negative. So we have P, still pick a representative. I think it's simplest for us to still pick this point, right? So Pxyz times the area here will be dx dy, and minus P x, y, let's say we pick this point. That will be x, y, z plus dz. And this multiplied by the area, dx dy, equals to 0. Oh no, not equal to 0. Because we have another effect, which is the gravity. So gravity acts in the negative z direction, right? So what's gravity? Gravity is just the rho, which is the density, rho g times dv. So that's dx dy dz. So hold this thing will equal to 0. So if we still divide both sides by dx dy dz, now what do we end up with? We end up with pz minus p z plus dz. This we need to divide by dx, dz, right? But here we have a dz, so that just cancel out. This thing is equal to rho g. Let's put this term to the right hand side. So rho g, we can give it another name, which is called the specific gravity. Let's call it gamma. And as dz tends to 0, what will happen? This thing becomes the negative of the partial derivative of p according to z. So we end up with this equation, which is minus dp dz equals to gamma, or partial p partial z equals to minus gamma. So we end up with these three equations. And these three equations, we call it the hydrostatic law.